In this Programming for Artists tutorial, I'm going to talk about how we can change our console log statements to an actual program command that makes the ball go back the other way. So right now, every time our program goes, the ball just goes off the screen. And of course, our program tells us it's off the screen, but the program needs to be able to move the ball back. So what we're saying here is if x is less than width, the width of the screen, the ball is on the screen. Else, the ball's off the screen. And why is it moving? Because we're using this incrementation operation from the previous video, and it's adding 1 to the value of x. We could even go ahead and print console.log x to see that happening. So here we can see that value of x is increasing. So now what we need to do is have the value of x decrease. So let's go ahead and try that. So here we could go ahead and put x minus minus, a different type of decrementer. And now when it gets to the edge of the screen, the ball will bounce back. Except it doesn't bounce back. It gets stuck at 399. Why is that? Well, as the program goes through, it says, well, if it's less than width, it must be on the screen. Otherwise, go minus minus. But then when we come back through the program, we're adding to x again. There's no way for it to stay there. So what we need to do is change this to if x is greater than width. And then we can go ahead and put this up here. And we're just waiting for it to go off the screen. And once again, we get stuck. That's because we still have this increment value here. So what we need to do is have a different variable. We need to have a way to flip that incrementation of x. I'm going to go ahead and delete this else right here because we don't need this else statement. And I'm going to go ahead and delete these two incrementations. So what we need to do is have a new kind of variable. So instead of this a right here, I'm going to change this to speed x. And I'm going to make speed x be 1. And then let's just see if we can get this going back the way we had it. So I'm going to say instead of x plus plus like we had, I'm going to say x equals x plus speed x. And let's just see if we can get that working. So now we have the ball going across the screen. Excellent. So that's kind of the same thing we had before. Let's go ahead and add another variable. Let speed y equals 1. And we'll do the same thing here. We'll have y equals y plus speed y. So if we look at this now, this is basically what we had in our original program. So now how can we use this information to change our program? Now what we want is when x is greater than width, we want it to go back the other way. Well, there's a cool math trick that we can do. So we can go ahead and multiply speed x by -1, and it'll change its sign or its value. So let's go ahead and try that. If x is greater than width, let's take speed x equals speed x times -1. Now let's see what happens. Now you can see the ball comes back, but we still don't have any y. So let's go ahead and add another conditional. So I'm just going to copy this conditional right here. And then right up here in edit, you can tidy your code. So I'm going to go ahead and make this y if y is greater than height. And I'm going to delete this console log ball on screen because we don't need that right now. And we can have it console log y. And then this will be speed y and speed y. So now if we watch, the ball should come back the other way. And it does. But now it is going away forever. It's not coming back. How do we get the ball to come back? Well, we need a new conditional comparative operator. So far, we've just been using less than or equals, but we can combine comparators. So we can use and or. So I'm going to put a comment right here. So and in JavaScript is written as 2 ampersands. And then or is written as 2 pipes. So we can use this. Let's think about how we could do that. So it's greater than the width and it comes back, but then it gets stuck over here. And remember, 0, 0 is at the top left. So let's try or x is less than 0. And then we can try the same thing down here with y. So then we can say or y is less than 0. And so now our ball should be moving and bouncing back. And as a bonus, it automatically has this simulated physics that bounces off the walls. Now, if you see here, we don't actually have the ball hitting right on the edge. We would want to change how that is calculated. So we'd want to have it with minus the size of the ball. Right now, this ellipse here has 100, so we'd want to take off 50 of that. So we could put in a parentheses here, y height minus 50. And we could do y greater than 50. And so now it looks like it is bouncing right there. This would be better to replace with a value, so a variable. So we can come up here and we could say, let ball height, do ball h equals 100. And then we could go ahead and write ball h right here. And then instead of having this hard-coded value, we could write ball h and then ball h. And so that way we can change the height of the ball when we need to. Here we need ball h divided by 2 here, less than ball h divided by 2. So now we have that working, and if we change ball h's value, we could change that as well. Let's go ahead and add a ball w. Let ball w equal 100, and then we'll change everything right here. So now we can go ball w. And if you wanted to keep it a circle, you don't need the width and the height. I'm using an ellipse, so I have the width and height. You could just have ball size and then put the same value right here. In fact, let's go ahead and do that. So we can just write ball size, and then right here we'll write ball size, and then right here ball size. And then we can come down and change this. Instead of ball h, we can write ball size as well as ball size, and then that way we could have this same expression right up here. So we could go ahead and put this right there, and then we could paste it there as well. And now it should be working. And I don't think I need these parentheses, so I can take those off because it knows the order of operations. And so now we have the ball actually bouncing off the edge. Now, to make this a little bit more exciting, we'd probably want to go ahead and have the ball squish and things like that. So that'd be a nice experiment to try. We can also, as a benefit, since we're using variables, we can go ahead and change the speed. We can have different x and y speeds. So we can have 11 on the y, and you can see now we get this much cooler random action, which is a lot of fun. So we could even have these speeds be random based on when the program starts, but we'll talk about random and ways of getting variability in our program later. So go ahead and try it out yourself. Maybe experiment with the speeds, maybe try to have the color change when it gets to either side. So instead of having this fill be right here, we could put fill up at the top in setup. So we could go ahead and say fill is in the setup. So it runs once and it tells it that. But then we could have fill here and it'll be the same, except then we could have random. And now each time it hits on the X, we're going to get a different color. So see if you can control that with more deliberate actions. And we'll talk about the random function a little bit more in another video. But this is a great example of how to use conditionals to be able to have your ball bounce around the screen and use this logical statement here of multiplying by -1 so it flips the direction or the sign of the variable. Happy programming!